Hey guys, it's Jam. We are going to check out Fast Farmer, and Fast Farmer was written by Luna at Evergreen, and I've been testing out the beta versions on my big farms, and now I have it working on about 50 petabytes between two giant farms, and I'm very, very impressed with it. So the reason I'm using it right now is there was a huge reduction in latency with the Gigahorse as far as the plots loading because it's async and multi-threaded for the plot loading, as well as reduction in latency for the harvesters. This is there's two modes that the Fast Farmer has. I mean, I'm not talking about the TUI and CUI. These are just ways to run it, but there's a way to run it with a local node, which is you're running your own version of the Chia, just like the Chia client, like you normally do. And then there's a version you can run it with a community node. Now, this is extremely helpful if you're on like a NAS or something like that, where you just don't. It's not convenient to run a full node. So with that, we are going to dive in. All right, so now it's time to do the initialization and test out the Fast Farmer. So if you download the Windows folder from the GitHub, or you can go to fastfarmer.io and basically download the Windows exe. You can unzip it into a folder. You can see here it has a file called ffgiga. And so what we're going to do, I have actually put if you look in this folder, I have a blank folder called SSL, and if I look, blank, I have the CA folder from the. If you copy over, it's dot. Let's see, C home users. It's dot Chia mainnet config SSL. You'll see this CA folder here. So you just need to copy paste this into a blank folder SSL if you're going to use the local host. You'll see, or we can use the community node, which doesn't require the certs. We're going to try both just to show you guys how it works. All right, so now that we have the Fast Farmer downloaded, what we're going to need to do is do a Chia keys show mnemonic seed to get your key, and you can put that in a key file or just copy paste it in. Obviously, don't show this to anybody when you're doing this. It's very, very sensitive. Even if it's just your farmer, you don't want anybody ever having access to your mnemonic. This is a test, test 3. This is a test thing, so I don't care here. I'm just showing you guys. And then you're going to need to do a Chia plot NFT show because we're going to need to find our launcher ID, and of course you're going to need the pool contract address for plotting. So what we're going to do is copy this mnemonic seed. We're going to do a ff giga init. We're going to put in our mnemonic, and we're going to put in, I just put my first wallet address as the payout, but you can put whatever you want. If you do C, it's going to be a community node. We'll show you how to change that later. And plot directory, I'm going to do dplots, and that should be it. And you can put your plot NFT in here for your launcher ID. I would put this in here to be safe, but if you leave it blank, it should find your launcher ID if you only have one. I found if you have multiple that it might only find one. So I would be very specific here and put your launcher ID that you want to farm with in here. And okay, so now this generated the config. It's going to, we're going to cat, it's going to go by default into C users jm.config fastfarmer fastfarmer.yaml. And if you see here, we want to just open it in VS Code. I just pop it up here. So by default, it's going to, if I put community node, it's going to use their node. So you don't actually need a full node sync to do this. So this is really nice on a NAS or something where you don't have the full node handy. Doing the init is going to generate this farmer info, this farmer secret key and the launcher ID. And this needs to be in there for the farmer to be able to farm because it needs to communicate with the full node. And then your plot directory. So we're just going to test out this basic config and see if it works. So we're going to do ff run. So checking our certs from the pool. And oops, I can pull this over here so you guys can see it out of my view. So you can see here, it is farming away. So you can see here, processing signage point, 0 seconds, Gigahorse pass filter. Let's see if I can actually make it a little bigger and see. Yeah, this should be very fast because I don't know if it's actually going to show up here in NVIDIA SMI, but yeah, we should be farming away. Okay, so we're going to cancel that. I usually run with mcli. This is actually much easier to read because you can put it into a folder. Oh, Chia using one CUDA device. Cool. So it's just using our GPU here to do the farming, which is awesome. Again, this is only compressed to, these are the plots passing the filter. Obviously, the time taken is going to be 0 until a plot passes the filter. I only have 2 plots here. So what we can do is like go into the pool that we joined and change the difficulty if we really wanted to. But I'm going to show you, so this is how to do the default setup. And so we're going to cancel this out and we're going to edit it out and we're going to try from the local nodes. This is the community node. We actually want to, I actually am running a Chia node here. You can see here a little Chia blockchain guy. I'm actually running a Chia GUI with a full node synced on my Windows desktop, so I can basically use the Chia full node on this. I'm going to show you guys how to do that. All right, so now we're going to try it with our own local Chia full node. So I'm obviously running the GUI in farmer mode, so you can see the full node is synced with the Chia show. If you didn't want to run the GUI, you could just do a Chia start node from the command line without running the GUI, and this will run in the background, which is really nice if you're running this fast farmer. But yeah, okay, so you can see the full node is running here. So if we do we need to change the config. So we got to go back to our config here. We need to open it up, which is in C users jm.config fastfarmer.yaml. I'm going to open it up in VS Code. And what I'm going to do is our root SSL path. I'm going to put, I have a folder here in this, like I said, in this folder, I have a folder with the CA folder. This is from the Chia. Again, because I want my node, my fast farmer to be able to talk to my Chia full node, and they need certs. And so you just need the CA here, and this fast farmer is going to generate new certs for the farmer so that they don't conflict, but they're using the same keys. So we need that. And then we want to change this to localhost. But if you were on, if you were on a network, a local network, and your node was on another machine, you could do 192.168.1.10 or 20 or whatever the node is, right? So I'm on local. This is running on my machine that I'm running on, so I'm going to run on a localhost. The full node port for farmer is going to be 8444. We're going to also change the this one to localhost and 8555, and that's it. So we're going to save this. Whoops. Save. And now we're going to run this again. So fast farmer run CLI. So it's going to, again, spawn the Chia is running to do the decompression, and it found our certs, and it found the full node. So if we do a Chia peer full node -c, you'll see our little fast farmer down here in the bottom. This is the regular farmer that's being run by the GUI, and this is our fast farmer down here. And you can see fast farmer is just chomping away. I don't think we have passed the filter yet, so the GPU's not gonna do anything for the decompression until we pass the filter. This is only 2 plots, of course. It may take a while. So, but you can see here it's running now. I'm running off my own local full node, and again, one of the other cool things you could do is you can have now a bunch of these running on a bunch of different hosts, and they're all pointing at the same full node with the IP address on your LAN. You just have to make sure that your firewall is all set up correctly. All right, so I wanted to show you guys a little more advanced, slightly more advanced setup, which is, this is my system on Linux. I have 4 hard drives filled with, can't remember, C33 or something like that. Let's see, HTTP1. Yeah, or C32. Okay, so again, this is a little box, and it doesn't have any GPU in there. Video detector, none. So no GPU in here. So how are we gonna do the harvesting? So this is where you can use the remote decompression, which is really, really nice. So if I basically show you in my fastfarmer.yaml here at the bottom, I can show you this recompute host. I'm going to set as my Windows machine 0.43, which so now we need to actually start the recompute server. So what I'm going to do is go to C users document GitHub. I'm going to go to Chia Gigahorse, and I'm going to go to yeah, it's Chia POS, I think. Windows is where it is, and you'll see a bunch of things here, and one of them is called Chia Recompute Server. So this is just on my Windows machine. I'm going to run the Chia Recompute Server, and you can see it's going to start here using one CUDA device. It's going to use my 4090 here. So if I go back to, let's see, whatever, that was the, oh yeah, H370. This is the Linux box. Again, this is a Ubuntu 22.04 install. So what we're going to do is basically run this fastfarmer Giga, run mcli, and this should be interesting now because we're actually farming. It's going to have to load up 90 terabytes worth of C32 plots on, and it's going to use my Windows machine as the decompression server. And now there's a bunch of other cool ways. I'll show you guys how to use a remote decompression server like on RunPod or something if you don't have a GPU handy. But this remote decompression is actually one of the most cool and used features of Gigahorse that I use. So here's just loading the plot. Okay, we found the certs, loaded the plots, 2,461 compressed plots, and we are off to the races. So now you can see here we should be getting events from 125. That's our fast farmer, and use GPU equals 1. If you have a used isFail is 1, that's bad. You need to restart the decompression server. Sometimes it happens on Linux. The NVIDIA driver just like decides to go away or something like that. But so you can see a C32, the latency is going to be pretty high, even on a 4090 on Windows. About 1 second, for decompression. But yeah, I don't know. I haven't tested this C32s on Linux, so I can throw one of these 4090s on Linux and see if it's any better. But you can see here it's working, and we are farming away. So you can see here compressed when that 6 out of 2,461 is how many plots pass the filter, and it'll tell you finish processing in 4 seconds. So that will be the total time of the total latency of the disk I/O for the lookups as well as the decompression events as well, which you can see obviously the decompression in this case is taking a lot more time than the disk lookups. So there you have it. That's a way to use the Chia remote decompression with the Chia Recompute server. All right, the last thing I'm going to show you guys is the metrics server, which we're going to try to replicate what we did in Chia Exporter, but with fastfarmer, so we have some metrics for the harvester. So I'm going to do this on Linux, but the Windows has Docker and Docker Compose, and it's exactly the same way on Windows. I can show you guys how to do that, but this will be more interesting because I have more plots on this one. So we're going to do a git clone of my repo here, scripts, and we're going to go into scripts and monitor GPU. Let's see if we have Docker on this system. So we don't. So what we're going to do is go to install Docker Ubuntu. You basically copy this here, put in your sudo password, whoops, where we just got there we go. Then we got to copy this one. It's going to install Docker. Yes. And then the last thing we want to do is go to post installation steps and user mod-ag dockers. We're adding JM to my Docker users. So we're going to do that. Next. And then exit. Come back. After you change permissions, you have to log out and log back in. So now if we do a Docker, you'll see Docker is installed. So we're going to go to scripts, monitor GPU, And we're going to nano compose.yaml. And so this is the compose.yaml we have. So if you have an NVIDIA, if you have a GPU on the system, you can run this last one, but we don't have that run, so we don't need that. So we're just going to delete that and run. It should so this is just going to run Node Exporter, Prometheus, and Grafana. So we're going to Control O and save, and then Control X to exit. Now we need to edit the Prometheus.yaml to basically include our new job. So this job is going to be for, let's see, Fast Farmer. And it's going to be running on, this IP is 168. We'll just make sure we're running it on the right IP so we don't screw up. Sometimes Docker gets a little confused here, and we're running it on port 8080. I'm trying to remember if we need any other configs in here, but we'll find out here shortly. So now we just do docker compose up-d, and it's going to run and pull all these Docker containers. So it's going to pull Prometheus. I'm running MySQL backend for Grafana because this is kind of more of a production version. You don't have to. The default runs SQLite. It's going to pull Grafana. It's going to start all these. And so now, if you do, you can say Docker logs Prometheus. It's running. Docker logs Grafana. It's running. All these. So you can do Docker PS. We'll show you all the Docker containers running. Yay. Okay. So we are going to go to now 1.2. We're going to go to 125-3000 because this is the IP address of the little server. Oops. HTTPS. Wait, is that the right IP? Yeah, 0.125. There we go. Admin. Yeah, no, I don't want to change the password right now. You're going to add your first data source, Prometheus, HTTP 192.168.0.125. So 9090 is the port for Prometheus. And so we're going to add our first dashboard to make sure things are working correctly. So we're going to 1860 is the one for Node Exporter. So just do that to make sure things are working. Yay. Okay, last 5 minutes we can see, this thing is working. So now we are going to add the dashboard. We're going to import, and we are going to copy and paste the JSON. We're going to have a link to this on, by the time this video is up, the JSON should be somewhere for the Fast Farmer. If it's not, I'll put it in my repo. But Luna has created this for me. So we're going to import it versus import it with the JSON. We're going to Prometheus data source, import it, and here we go. So we're going to load this up for a sec. Oh yeah, it's not going to work because we're not running Fast Farmer yet. So we need to run Fast Farmer, and we need to run the decompression server again. So we need to make a slight change to Prometheus.yaml. So if you ever have to do this, you just basically edit Prometheus.yaml. I forgot we forgot a few things here that we want in the. Whoops. We forgot a few things that we need here in the Fast Farmer. So we want to keep the static configs, but we want to add a scrape interval and a scheme HTTP. And if you do this, we just do docker restart Prometheus, and it's going to suck up the new Prometheus.yaml. Well, this would help. I had metrics enabled false in the config, so we're going to have to stop the farming and nano.config fastfarmer.yaml. So it's a good thing I'm messing all this up for you guys so you can figure out how to debug stuff yourself. So enabled true, and now we're going to restart Fast Farmer. And now we're going to wait a few minutes and come back to the dashboard. And there we have it. So we waited a few minutes. I'm just showing the last 15 minutes. Obviously, the default is 24 hours, which you can't see very much here. So we'll zoom into 5 minutes, and you can see the latencies, going from, 500 milliseconds to about a little over 2 seconds, which is not surprising because these are These are C32 plots, and we have about 90 terabytes of them. So 2,461 plots. So this is kind of similar to the Chia dashboard, right? We have it's grabbing the full node status from the RPC from the local node. It's grabbing the full node height and the net space and all that stuff, which is great. And then you can see compression breakdown. We have C32 and K32. So C32, K32, fun. And there you have it. So when you win a block and you do partials in the pool and stuff, they'll show up here. But then now you have a little dashboard to monitor your fast farmer.